welcome everyone to this August community call for Hasura. This is our 46th edition, which is getting crazy to think about how far we've pushed along through all of this. We found a lot of success last month, if you were here with us, by moving our customer spotlights up. So we're actually going to begin our call in just a little bit by talking with Chris Smith of Lumanu. I hope I'm saying that right. And we'll be talking about how they've used Hasura, the benefits they found, kind of what they do, what Chris does, all those different things. From there, I know a lot of people are here because of a very exciting announcement that we had today where we are iterating on our business logic and Lambda connectors by adding support for Python. So a lot of cool work done there to take a dynamic language and make it somewhat statically typed by Tristan Har and brought in, and he's going to demo that for us today as well. From there, we're going to kick to a couple of other topics, more around DX and kind of workflows than anything else. We'll talk about schema registry and diffing with Suraj and see some of the great observability tools that we have through usage analytics. And then finally, something that we've been really excited about, but we haven't had a chance to demo for all of you folks yet, is our new ultimate developer experience. Internally, we've been calling this our magic workflow because it just makes the commands so simple and so easy to use. It really makes working with the CLI and kind of that day-to-day iterative workflow a pleasure. So Akshaya will be on with us to talk about that. And then we'll wrap up with some product updates before sending you folks on your way. I'm going to go ahead and jump to our next slide, which I know you folks can't see right now. But we have Chris Smith of Lumanu with us today. So Chris, would you mind going ahead and joining me up on stage, sir? Chris, how's it going?
Ooh, great. How about you?
Doing well, man. Thanks for being here. Have you come to community calls before? Is this your first time?
I have.
Yeah.
No, yeah, I've been on a couple. Yeah.
How do you feel being on this side of the camera as opposed to how it was before?
Yeah, it's intimidating for sure. Yeah.
Okay. All right,
We'll
cool.
see how I do.
No worries. Well, Chris, do you want to just give us a little bit of background about yourself? I know you and I talked last week. You said you're out of Greenville, South Carolina. Always nice to have another Southerner in the call on the occasion. I'm down here in Alabama.
Yeah.
So yeah, tell us a little bit about you, and then we'll kind of shift gears into everything else.
Sure. Yeah. So, yeah, as Rob mentioned, I'm in Greenville, South Carolina. But we work remote at Lumanu. It's a pretty distributed company. I've been in software development for over 20 years. About half of that spent in consulting and like some software development. So worked across a bunch of different stacks, and that's kind of how the story with Hasura started. Um, so I kind of brought that over from my days in consulting as a tool that we used, from proof of concept and some smaller projects um, before I came to Lumanu. So yeah, that's me. And Lumanu is a tool to help marketing teams and agencies streamline their payments to the influencers and maybe other contractors that they work with. So we try to solve this problem by becoming a master vendor for them. So if you think about traditional procurement processes, when you go to hire a vendor to do something for a company, it's a pretty slow process, and it's not very agile. And in marketing, it's all about time to market, speed. And now in the creator economy, there's a lot of different vendors that they're working with. These influencers are vendors as far as your finance team is concerned. So they're going to put them through the same process that they would, another company that you're working with. So what we do is we act as a master vendor. So we're the one vendor that your finance team can look to for payments. And then what we do is allow the marketing teams to actually control the payout process. And at the same time, we still give the finance team the visibility and access to the financial part, integrate with their accounting system. We handle all the compliance and tax reporting and all that kind of stuff for them. So it's a nice way to kind of help those teams move a little faster and work with kind of a new paradigm in this economy we have.
Yeah.
Yeah.
New paradigm is a good way of putting it, right? And before we kind of jump into the technical side of things, I'm just curious, how do you feel about that word influencer? It's perfect.
We go back and forth that we internally say vendors, because that's really what they are, right? It's not just for influencers, it's not just for creators. They do have this problem where they do want to be more agile across, really any kind of contractor. So it's not a favorite of mine personally, but yeah. It is what the industry uses.
Yeah, for sure. That's a cool way of thinking about it from the perspective of vendors. And so when you and I talked last week, you kind of said that, the role that Hasura plays more than anything else is it allows you to kind of make cheap bets and cheap experiments, not only in terms of the, like dollar cost associated with things, but also kind of in like rapid prototyping. So could you talk a little bit about that?
Yeah. So we, when I joined Lumanu, we had started out doing sort of just like traditional, code everything development. And what we were realizing is that, yeah, as a startup, as a young company, you got to have a lot of at-bats and you got to keep trying things. And as our team grew, as our technology stack and what we were trying grew, we realized these bets were just getting too expensive. It took us too long in terms of time to do something. It's a lot of cost, a lot of infrastructure we had to spin up to support these things. So yeah, like I said, I used to be in, kind of a bit of a scrapper in the consulting, trying to put things together. So I kind of drew on that, pulled Hasura out of my pocket. And to my leadership's credit, they bid off on the idea of rewriting our stack based on this proof of concept that I did, where I think we looked at a bunch of other things, right? There's a bunch of tools out there that kind of do similar things, but I mean, we couldn't do anything any better than what we did with Hasura. I mean, within 40 hours we were moving fake money around, and we had the core of our product kind of rebuilt. It was programmer UI, sure. I mean, it didn't look pretty, but it did all the things that we thought we needed to do. So we built that proof of concept, and we decided to base our rewrite on that, and we got that done last year. So yeah.
It's always good to see that fake money moving around whenever you're working on an e-commerce API. Just feel
Yeah,
like you're
yeah. I
invincible at
did it in
that
the
point.
sandbox. I didn't move any
Yeah,
real money. Yeah.
So you said 40 hours for the proof of concept?
Yeah. Yeah.
That's
We looked at
impressive.
some other things, and they were at the point where I was like, okay, you can log in and you can see a list of something,
Sure,
but to be actually have the core of the product in that amount of time was just a no-brainer for us to rebuild on that.
definitely. Well, if folks want to find out more about Lumanu or more about you and your work, where can they go?
Lumanu.com is the best place.
Okay.
Lumanu, and it's
Nice.
Lumanu, not Luminu. We've had that question.
Okay. You can imagine that we get a lot of questions about our name as well. So yeah.
Yes, yes. We're not sure internally. It's a little different for everyone.
Fair enough. Fair enough. Well, Chris, thanks so much for joining us today. If you want to stick around in case anybody has questions, Chris can be around on the
For sure.
chat. Yeah, hope you have a great rest of your day.
Absolutely.
Thanks so much. Next up, like I said, I'm sure a lot of you are here for what we have today. If I can actually track these things away, the joys of Zoom's UX. Tristan, how are you, sir?
Hey Rob, I'm doing great. I am super excited about this one. As you know, a lot of people at Asura and people maybe who have been on previous community calls know, I'm a pretty big Python nerd. So we've got some really exciting stuff today, I think. You are able to host Python code now on Hasura's data delivery network, which is just insane, especially because, normally with GraphQL, it's strictly typed. And so you might be wondering, like, how does Python play into that? So super excited to actually start off. I've got a video that I think we're going to be able to share that'll kind of give a little overview of some of the functionality and capabilities. And then if we have some time, I'm going to jump into a screen share after and show off some federation stuff with Python. And we're going to start by jumping into a little bit of code. So with this Python connector, as we'll hopefully be able to see here in the video in a second, it's really neat. You're actually able to use a decorator here to register queries and mutations. And so in this example, we have an isExpired function that takes as a parameter a timestamp, which is a string, and it will return a Boolean whether or not the timestamp has passed, right? And so just to kind of give an example of what this looks like or how this works, I want to talk a little bit about relationships now. So when we talk about building relationships, right, with HTML, which is the Hasura markup language, we're actually able to define a relationship from a Postgres table where we have coupons to a function. So this is really cool, really powerful stuff. I'm going to switch my share. So as you can see here, we have the coupons table, which is from our sample database. And I have this is coupon expired field. That's actually a join from the database to the function, which is really, really cool. And what we also have with this is we have the ability to join not only from functions to, or from the database to functions, but we also have the ability to do joins from the output of a function to the data, which we couldn't actually do that previously with Hasura v2, right? If you've ever thought about like action to action joins, or you've used Hasura v2's actions, this is really powerful because we can actually say, okay, let's take the output of this order response and say I wanted to build a function, Rob, that let me get the orders by status, right? Where I said, okay, here's a list of the statuses and I want you to go get me all of those orders. Now, traditionally you would do this with the Hasura query where you can use the where filtering, right? And you could say where, but let's imagine that that wasn't available. Maybe you're working with a weird data API, right? What we could do is we could create a function that would return this response here with a status that is a string. And then what we can actually do is create a relationship where we say, okay, we want to take the orders table and we want to have a array relationship on that get orders by status function. And so what's really cool there is we are able to, let me just switch this again. Sorry, a little bit switching around here. We're able to do something like this where now I can do this query, get orders by status. And what I can actually do is it's performing a join from the function to the data. So really, really powerful there. You can imagine a lot of the capabilities that we're going to get from that. And then the last little thing I have to show off here, and then hopefully we'll be able to dive into that video, is the ability to you can also do function to function joins, and this is really cool. So as an example, I have this these two functions here. I have this function called chain, and I have this other function called chained, right? And what I can actually do is inside of the metadata, right? I can define a relationship where I can say, hey, I want you to take the output of one function and I want you to use it as the input for another function, and I can chain these functions together now. And that's Hasura doing all of the work. So the Hasura GraphQL engine and Hasura DDN is going to go ahead and allow us to chain these functions together. And if you look, of course, we get something that is lightning fast, and it's going to call the first function. It's going to grab this first piece of data and then pass it in as a parameter to the second function. So really cool, really powerful stuff. And now hopefully we've got the sound back working, because that is what I had for that demo. And now we can maybe show off a little bit more of the capabilities and how you would go about writing some of this code and setting things up.
We're going to do a deeper dive into these functions to demonstrate the different capabilities of the Python Lambda connector. We'll start simple by looking at the hello function. When you work with the Python Lambda connector, you'll make use of decorators to register queries and mutations. For example, you will use the register query decorator to register a function as a query. For example, this function will become this query on your graph. When you execute this query, it will call this function. Queries and mutations can be synchronous or they can be asynchronous. And it's also possible to pass optional parameters, such as in the nullable hello example, where, as you can see, the name is of type string or none and defaults to none, which turns into a query where you can call app nullable hello. And if I do not pass a name, then it's hello world. And if I pass the optional name parameter, then it will say hello Tristan. Since this is Python, it's also possible to leave untyped parameters, such as in this mutation called SumMutation function. If I go ahead and run a mutation and call SumMutation function, I can pass a parameter that is a string, or I could pass an integer or a float or even an array. You can also use pydantic models as inputs and outputs for your function. For example, this greetPerson function takes as a parameter a person model, which is defined here, and returns a string. The person model has a name and a pets attribute, which is a list of pet models. Let's look at what the GraphQL for this looks like. If we want to call app greetPerson, we can fill out a name, and pets is nullable. So if we do not add pets, it will say, hello, Tristan, I see you don't have any pets. However, if I did have pets, I could add an array of my pets, and it would say, hello, Tristan, and hello to Fido. Types can get quite complex, and they can be used as inputs or outputs for your functions. When the output of a function is a specified type, you can use GraphQL to specify which fields you want returned. For example, I can get all the fields from this function returned, or I can choose to only get some of the fields that I want. I can even make use of aliasing to change the response to look exactly how I want it to. The SDK makes it easy to do tracing using some of the utility functions that are provided, such as the withActiveSpan function, which allows you to trace your code. Here we can see that span we added, along with its attributes. You can also register functions to run in parallel.
So yeah, that's a little bit about the Python Lambda connector, Rob, and hopefully people are excited about it and going to be able to make use of it.
That's lovely. I know that we were talking a couple weeks ago. I was saying I haven't touched Python in a long time, so it's been quite a while since I've seen decorators for functions. But it's a nice thing to see a dynamic language like this now become statically typed. So well done, Tristan. Thank you so much.
Yeah, thank you, Rob.
Next up, I'm going to bring onto the stage Suraj, who's going to be talking to us about Schema registry and some observability tools that we have inside of the console. For anybody that's used V2, there should be some similarities here for a tool that we launched probably close to a year ago with Schema registry. We'll be looking at a schema diffing tool that we have inside of DDN. So Suraj, whenever you're ready, go ahead and join us up on stage, please.
All right. So today I'm going to talk about the model and field analytics in DDN a little bit. It's so exciting if you have tried connecting DDN with multiple data sources, and especially when you think about metadata driven sort of data access layer. When it comes to the metadata driven access layer, or when you think about building a super graph like as an entire data domain graph, it's so important to know which part of your data is being used, right? And that is the exact problem that we are trying to solve with this, model and field analytics part. So before we jump onto the demo, I will talk about, I'll brief through the quick features and then some use cases so that we all can relate to what is happening. So the features around the data and model and field analytics is mainly around, you get to see the historic usage of the frequency of usage of models and fields. Basically, you'll get to know how frequent is this particular model is being used, or how frequent is this particular field is used. So when you translate that into a database kind of a scenario, you'll also what you basically get to know is like, hey, is this particular table being used like this much, or this particular column, or how frequently this particular column is being used. Accordingly, you can basically, make decisions, like informed decisions. And secondly, you'll get to know how these data is being used, the access patterns, whether it is accessed directly or as part of a relationship or via a particular argument. It also gives you a sense of the depth of the data queries, so that you'll get to know whether the model is consumed or used in as a direct query, or even nested too deep in the GraphQL query. It also helps you to understand or make deprecation easy. We'll come to that in a bit on the demo. I'll keep it for the demo. So on the use cases front, basically you can think of things like you'll get to know the frequently used portions of the data. It'll help you in deprecation. It'll also help you identify in setting up like a sense of the unused fields. That way, it basically helps you to identify the resource intensive portions of your data graph and then make decisions on it. It can also tell you how much you want to invest more in your backend to make it like more performant or maybe like smooth enough. For example, if you notice some fields being used or maybe like some patterns in the data in the GraphQL or like the data access patterns, then you can think of optimizing it further by introducing some stored procedures or maybe whatever works well for you. But the point is that you get the data in which like how your supergraph is being used. And the last part of this is very interesting, because if you want to design some data pipelines or maybe like even read replicas, it will help you to design that elegantly based on what you exactly need. It's not like you blindly make decisions or maybe like making data pipelines which is not even like worth that much. So you can get to know like how much is this portion of your data graph important, and then based on that you can make decisions. Quickly going to the demo. So for that, I'm heading to the DDN console. And I have set up a project wherein I have a supergraph, which you can relate to an e-commerce example. And here I have a bunch of models, and then I have a bunch of, supergraphs, subgraphs, and then models underneath. So I'm going to create a nested, like a decently nested query. So I'm going to query this field, this model called cart, and then I'm querying the fields like ID, user ID, and then I'm also trying to query a field which is deprecated. So in this example, you can see like each reminder set is deprecated, and I'm also having a reason for it, like just for the demo purpose. And you can also see I have a relationship back to users, so that whenever I'm querying a cart, I can get back to the user and then query these things. I'll show you why I'm doing this in a bit. So now I'm gonna make a query now. All right, so we got the response. So now what I can do is I can go to the Insights tab, and then I can see a new section called Analytics here. And then underneath Analytics, you can see the whole supergraph listed on the left-hand side, and which also helps you to understand which subgraph each of them belongs to. And then if you click on a particular model, in this case, I'm going to click on this cards, because we just made a request to cards, right? So here you can see the historic usage of that particular model. It gives you by default like 30 days of data. And then you can see like the number of hits on that particular model. It not only gives you the sense of the hits, it also gives you the sense of how these models were like used in terms of different queries. So as you can see, the query name is also visible here. Basically, you get a sense of like highest queries and lowest queries. So this is mostly the summary of a particular model usage. And here you like on the bottom, you'll get the like the detailed view of the model usage. So if you look at a particular query, so let's say if I click on the first one, I get to know how deep is this query structured. So if I click on it, it'll tell you like this query has like multiple nesting. So it shows me the degree of nesting as depth. And it also tell me like whether it is a query or like mutation or whatnot. And then it also helps you to understand the number of hits on that particular model. All right, this is cool in terms of model analytics. Now let's jump on to the field part. So this is more important if you think about a database scenario, or maybe like even a function which has like multiple fields returning based on a condition or something. So if I take an example of a SQL database, maybe what you can immediately identify is, see in this summary, like field summary, what you can see is like the fields with highest request and the fields with lowest request. And these we have categorized into like 3 sections, which makes the most sense when you think about optimizing your graph, or like when you think about understanding what's happening under the hood. For example, this view kind of gives you a sense of what are the field that gets most hits and least hits. And it not only tells you that if any of these fields are deprecated, it shows upfront, so that if you are planning to deprecate this particular field, when you click on it, what it helps you decide is it ready to be like completely is it ready to be changed? Even after deprecating, is my consumers querying this particular field? Or am I ready to be completely deprecate this particular field? Right. So these kind of queries, these kind of insights make it really smooth in terms of understanding what's happening under the hood on your data domain. And what more it can tell you is some cool features like this. Say, for example, if I have this query, sample users, and it tells you this is reminder set field was used in this particular query via a relationship. But it also tells you what is the relationship, backward relationship to that, like to a particular model. Because when I see a relationship, usually on the other places we see like, hey, this has a relationship to this particular thing. So now you get a backward view of what's happening, right? So in this case, you can see like is reminder set was queried from the user's model. So that level of visibility is what you're getting, with this field analytics bit. And then on any sort of historic view, you can again like filter on the dates and get a elegant view of what's happening. In addition to that, what you get on the field analytics bit is like you'll see the ID, like each of these fields, how these are accessed in a different shape as well. Because the previous section was all about the summary, and here you'll get the holistic view of what's happening. It's paginated, and also you get the complete view, even if the number of queries are different, like unique number of GraphQL queries are different, you'll get the complete sense of how it is. So this is really useful when you think about a lot of consumers using the API. For example, in your organization, probably you'll have like a bunch of teams consuming your data. Then you get a sense of what kind of queries they're using, how they're using. Is it like the proper way to construct, or is there a better way I can suggest so that they can optimize and get a performing output? Yeah, let me quickly check. Yeah, another thing is argument. This is very useful because as we talked about relationship, here we talk about argument. So what I mean by that is like here when you when you use ID as an argument here. So in this case, as a work condition, basically it's querying your database with this particular condition, right? And what happens is when you notice a lot of argument based, like a lot of field access as arguments, then you can make a call on whether I need to add an index on particular column, or maybe like some other optimization that I need to do, or maybe even adding some replicas or whatnot. Yeah, so the whole idea is that you get a sense of what's happening under your super graph, and then you can make informed decisions. Let me quickly recheck. Yep. I think that's all I have for the demo. I hope you all enjoy using DDN metrics.
All right, Suraj, thank you so much. That was awesome. I look forward to having people tell me about my queries and how they're inefficient, and I should be modeling my data differently. So thank you. We're going to go ahead and bring Akshaya up on stage, who has been with us on many a community call. We said that we're very excited about this next demo that we're doing because it really is what we've been calling internally our Magic DX. If you were looking at branch names inside of different repositories, you would have seen that as well. What this does is drastically streamlines the actual commands that have to be run and kind of that daily workflow and cycle that you'll be doing as an engineer using Hasura DDN. So Akshaya, go ahead and join me on stage.
So for those of you who've been following along, you might have seen commands like this as you use the CLI, and perhaps you are wondering what this is all about. Like this is quite complex. So we had a bunch of steps. We had a bunch of flags for each step. And a lot of people rightly asked, hey, what's with this? Could you not make it simpler? Like we're used to running an npm installer, Docker Compose up. What's with these commands? So I'm here today to tell you about some of the work we've been doing on that. And so let's add some magic to that. And what we went back and did is look at the flags, gave a lot of them a good default values, added an interactive mode to some of the commands, and built some more commands that sort of compose multiple primitive CLI commands together. And that got us to a CLI experience that looks completely different. So quick recap, to set up an API, you might have a data source, which is your Postgres database, Mongo database. You have a connector, which helps you configure how your engine is going to talk to that database. And then there's the engine itself, which is the GraphQL engine that serves the GraphQL API. And you can have different connectors. For example, the Python connector we saw earlier, or our TypeScript connector may not have a data source behind it. But then you just configure that connector with Python functions or TypeScript functions. And then you could actually get the engine to build an API off of that. So how do we set all of this up, and what do the CLI commands look like? So the first thing we're going to do is log in on the CLI. The second thing we're going to do is scaffold our supergraph metadata. So that's going to set up the metadata for the engine. Then we're going to come back and add the scaffolding for the connector, which is going to walk us through which connector we're going to use and some of the configuration. And we're going to actually see a demo of this, but I just want to express the model and then we'll do it again. Immediately after that, we want to configure our connector, which might look like setting up some environment variables or writing some Python functions. Then after that, we want to configure our engine metadata, which is basically telling it how to take the entities in that connector and bring them forward to the GraphQL API, which are things like models, commands, and relationships. Then we can go ahead and build that metadata. And then we can bring all of this up using Docker. So our connector configuration runs as a connector container, a Docker container, and the supergraph metadata runs as an engine Docker container. Yeah, that's pretty much the exact CLI commands that you're going to write out to get a local GraphQL API running. And then, of course, you can go ahead and create a project on DDN. And then you would go ahead and create a build of your API on the DDN. So the cool thing over here is these are literally the commands that you're going to be running. And we're going to go through them again in some detail. So let me just switch to my terminal so we can do that. All right.
Okay. Akshaya, would you mind pulling up the font size just a little bit, please? Perfect.
Is that good? Okay. So let me start with team 1 or team A. So I'm going to say, and then I'm going to run through these commands. So the first thing I'm going to do is scaffold my, a moment, please. All right. I'm going to scaffold my metadata. So I'm just going to show you empty folder. Okay, and if At any point in time, I'm sort of lost. I have a hint that's going to tell me what command I can run next. Let me just go into VS Code so we can follow along with what's happening. So team one, this is one repository, let's say, and that scaffold command has already set up my first subgraph. It set up the compose file, everything I sort of need to get going. The next thing I want to do is add a connector. So -I sort of puts it into interactive mode. So it's me to choose from a list. I'm going to go with Postgres. All right, continue with the defaults. There's a default demo Postgres database available, but at this point, you could also drop in your own database URL. And that's it. I'm going to type in the next command from the hint. So around that, let's just skip back to VS Code. Here's that connector we just added. So that's been scaffolded for us. That means we make a Git repository. What this is doing is it's going to go and talk to Postgres. It's going to pull the schema from our Postgres database. And then it's also going to go and inform the engine what this schema looks like. All right, so let's look at a quick diff. And you can see that the connector configuration has been updated, which is the schema from the database itself. And our engine metadata has also been updated with a copy of the same schema. And let me just quickly jump back. So far we've introspected the connector. And now we can go and add our models, commands, and relationships. So that's the name of the connector and a glob pattern matching the collections that we want to add. Similarly for commands and relationships, there are no commands on this connector. Let me add all the relationships. All right. And now we've generated all the metadata we need to set up our API. Let's go ahead and build this metadata. That's done as well. And at this point, I'm going to start up the Docker Compose containers. That's going to serve this API. So I'm just going to copy that from our hint and bring up the Docker containers. All right, that's weird.
Always the joys of Docker, right?
Not sure why that happened actually. Hmm.
So actually,
All right,
one thing I
then.
will say, just because it's like such a quick process of doing all of this, would you like me to try sharing a screen and running through? See if we can do a speed run and get it up?
Sure, yes, please.
All right.
This incidentally is the exact same as what we have on our quick start page. So for anyone following along, you can sort of go through these command by command, and the explanations are right there. Rob, over to you. I will see if I can debug this.
All right, so I'm in an empty directory inside of VS Code, right? I got my terminal open down at the bottom. I'm just going to go ahead and start off with TDN, supergraph, and init, and we'll put it in the current directory. As Akshaya said, right, we're going to go ahead and follow the hints. So I'll go ahead and initialize my connector just as we did before. And we'll do Postgres, and I'll call it my PG. Take the port, sample app, all these values. That's fine by me. I think you got to the introspection bit, right? So now we should see Docker spinning up in the background, hopefully. And if we look inside of our app subdirectory, we'll look inside of metadata, and we at least have our mypg in there. And now we can start adding our resources. So I haven't done this except for once, Akshaya. So there's now 3 commands here that I would use. I can do models, commands, and relationships, right? So I would do DDN model. Do I have to name the connector here?
Yeah. So
Okay.
you'd say in
My
model add
PG. Okay.
job pattern.
Okay.
Rob, real quick, one question from the audience. Do you mind zooming in on the terminal a little bit so it's easier to read?
Is that a little better for us? Hopefully so.
Perfect, thank you.
Yeah, absolutely. We know there's no commands in here, so I'm going to come through and I'll do relationship. Whoops. All right. And just as we noticed real quick, I want to point out, right? So we had all this output of the console, but we had this directory open as well. So Akshaya, can you tell us a little bit about like these individual named files that we had that are being generated right here?
Sure. So this is the engine metadata. This is configuring the engine to serve the API. And each file, so the way the CLI is generating these files when you add the when you run the DDN model add command. And the way it sort of does it is each file corresponds to one model. So in practice, what this means is for a Postgres database, each file corresponds to one table in that database.
Yeah, excellent. So I'll go ahead and do a local build, and then we can say we can go ahead and take this Docker command, and hopefully my Docker is behaving better than your Docker right now. And we're going to go ahead and pull some things down, which hopefully should be very, very quick. Excellent. And then let me open up a new terminal. We can pass the local flag to our console here. And of course, because I have 16 windows open, there we go. Now we have our local console up and running. So actually right now what we're seeing, right, is just going to be essentially a local version of what we just built. We can test it, we can iterate because we have watch commands that are running in the background for Docker. If I make any changes to that metadata, we'll see a rebuild happen, right? And then I'll have my API live for me right here.
Yep, perfect.
Sweet. All right. Anything else you want to talk about?
So that was the local API that Rob just showed us how to get set up. And now from there, what I want to do is take this same API and move it into DDN so that I can begin to serve it to other users. So then I'm going to do project init. The project init is going to go ahead and create a project on DDN. It's going to create our subgraphs if required and configure our local repository to work with that project. And then I'm going to do DDN supergraph build create. And this is going to build all our connectors, and then it's going to build the metadata and basically just give us a GraphQL API. Just waiting for this to come up. So here we go. And so this is our API and DDN. So I think if it's one thing that I wanted to convey during this call is that it's never been easier to get going with the Hasura CLI. I think at this level of abstraction, this is probably the simplest set of CLI commands that we can bring it to. Okay, so what happens? So how are we able to do this, right? So in a lot of cases, it just comes down to having better default values of flags. In some cases, for example, the DDN introspect command, this actually puts together a few of the underlying more granular commands. So introspect would actually go ahead and get the schema from the Postgres database itself, and also let the engine know about that updated schema. Another thing we've added is the context. So context is sort of a way to store commonly used flags or sort of configure your environment. Like for example, if I do DDN supergraph build create, now how does it know which project that build is going to get created on? Or what if you want to point the same supergraph build to different environments? Let's say you have a project for staging, a project for production, and you're creating a supergraph build for staging and you want to target it there. And later on, you want to do something in production. Or let's say you have different environment files. So for different environments, staging, production. So you could come into your context file and configure different named environments. The default one is called default. And the way you can think of this is whenever you run some of these commands, it would pick up the values of these flags from the context. So if you run a supergraph build create, it would pick up the values of the project and the supergraph.yaml is building from the context file. Federation is also very simple to get going with. So these are the same set of commands that we saw over here, except when you scaffold your supergraph, you just specify a different name of the subgraph to get going. And then everything else pretty much works the same way. Quick recap, Team A and Team B are going to scaffold their own repositories, and they can completely test their own subgraph locally. And when they're ready, they can go ahead and a supergraph admin can create a DDN project, create subgraphs on that project, and each team can then independently have work with their subgraphs on the same project, and then also create APIs from that. Okay. So back to the primitives. So we said, okay, the primitives are super complex. So why do we even have them? I just want to go back to some of these primitives and sort of speak about how, as a power user, some of these things might be useful to you. So whenever you get into more complex cases, if you have custom infrastructure, custom deployments, or scripting use cases, you will find that because our approach, so one of the advantages of this approach is that we can say to a very high degree of confidence that all of the use cases are accounted for. So this first command, for example, which was replaced with the interactive mode, you can still specify all the flags in the command line, which you might find useful when doing something like scripting, or if you want to, scripting, I suppose. The second connector link command, we sort of hidden away the connector link from our default quick start and our default day-to-day workflows. But if you had a connector that was deployed in your own infrastructure, and you just wanted to point your engine to that URL, then this command would come in use. And then, of course, the DDN supergraph build local command. This just is DDN supergraph build local, where we've sort of given a lot of default flags. But let's say you were working on your own repository and you wanted to customize these environment variables. So you wanted to override the environment file for that particular thing. You could either set it in your context, or you could just add the flags over here. Or for example, if you want to create multiple builds that you wanted to test later, you could just create a bunch of builds over here and then test them out one by one. Okay, so I think this represents a milestone in terms of what we wanted the CLI to look like. What's next? We're going to continue polishing up the CLI. There are a bunch of things that we want to continue improving just to get the polish right. In addition, we're very interested in hearing about workflows, especially day 2 kind of stuff where you're iterating on things. Like where in the workflow do you think that things could be smoother? That you feel the tooling could support you better. Whether you're setting stuff up or iterating, please do let us know, and we will look into that. All right, please do visit Hasura to get started. Quick Startup Docs is a great place to get started. And all right, thanks.
One quick question, actually. So for people that do want to give feedback about their workflows and kind of where they are seeing some kind of friction, what's the best method for them to give feedback to the team?
Right. So we're watching out on Discord, so please come and chat with us over there. We also have our issue tracker on GitHub. So if you hit any issues, please do come by our GraphQL engine repository, and you can drop your issues there as well.
Awesome. Thank you very much.
Thank you.
And yeah, there's a question in the chat about posting a link to Discord. We'll make sure somebody from the team gets a link in there. So no problem. We'll make sure that everybody has that available. And actually, I think that we may have it on one of the upcoming slides that I have here. So let me just go ahead and share screen, and we will wrap things up which it's looking like for the second month in a row, we're going to wrap up on time. So well done to everybody on the Hasura side here. I've got a couple of product updates just to kind of share before we send everybody on their way. The first is that we have a lot of new connectors that are now available for everybody. So if you go to the connector hub, again, that's hasura.io/connectors. This list of cards is growing by the day, and we're seeing more and more that have come through recently. We got some new connectors like Oracle, MySQL, Snowflake, and SQL Server as well. Please go check those out, give them a run, and see how you like them. Let us know, give us your feedback. Additionally, last month we talked a lot about an RFC for exposing REST endpoints from your SuperGraph API. And this month we're looking for your feedback on exposing as gRPC. So we have a link to a demo and then also an RFC that's inside of the resources here for gRPC. So do take a look at that and please let us know your thoughts. I'm going to jump back over here, and like we said, Discord, our Discord server is right there, and I'm sure that link's already been dropped into the chat for, I think it was Conrad that was asking the question. But we have office hours with Tristan, who demoed the Python connector for us earlier today, every Tuesday at 10 a.m. Pacific, so please do check that out. And on Discord, again, you can stay up to date with everything happening with DDN, talk to the team, ask your questions, find out what our favorite food is, whatever it may be. For a few helpful links that we have here, as always, we're looking for your feedback in a variety of ways. So please let us know if you want to be like Chris at the beginning of this call today and let us know a little bit about what you've been doing with Hasura and what projects you're working on. You can join as a community demo as well. We have a few upcoming webinars as well, which I was not super aware of, but this is exciting to see all the different things that are going on. You can see we're talking about MongoDB, lessons from building metadata-driven data layer at a Fortune 50 bank. I can take a guess at who that is because I was just having dinner with him last week. Data catalog governance strategies for API platforms, and we said data mesh, not data catalog. So if there's not enough data being thrown at you, there's some more for you right there. We even have another one. Look at this. Hasura and data catalogs are better together coming up in October. And we even have a GraphQL meetup happening in San Francisco. You can see that we have a couple of topics that are there. That's going to be September 5th from 5:30 to 7:30 at our office in San Francisco. I'm sure you can find all the information about signing up for that either inside of our resources or by hitting up our website. I've been Rob. Thanks for joining us today, and we will see you next month. Bye.